Hello students of class 11 and 12 CBSE Computer Science with Python. Welcome to TechBox 247. Hope all are doing good and preparing well for your board examinations. In this video, we are going to learn about operators in Python. Okay, come on, let us move on to the video quickly. So in Python, we are having 7 different types of operators. Those are arithmetic operators, relational, identity, bitwise, membership, logical, and augmented assignment operators. So we can say this augmented assignment operators as shorthand assignment operators. Make a note of it. So let us move on to the next part of the video. So we are going to learn one by one. So before learning to the types of operators, we are going to learn what is mean by an operators and what is mean by an operands. Okay, so let us read the definition for operators. The symbols that triggers the action or operation on data are called as operators. Okay, so the symbols which we are triggering, that is triggering an action or operation on particular data is called as operators, and the data on which the operation is being carried out are called as operands. Okay, so let me explain in detail what is mean by an operators. So it is given that symbols which is triggering an action or an operation on particular data. So consider A as data which stores a value of 10, and you can also consider B as another data which is having the value as 20. So now this data is having A and B, and it stores the value of 10 and 20 each. Okay, if we want to add it, we need the symbols. So like plus. If you want to multiply these two datas, we want the symbol as star symbol. That is a multiplication symbol in computer science. So if you want to add two datas, it can be added like this. If you want to multiply any two datas, it can be done like this. So which is called as an action. So the multiplication is nothing but some action is performing on both the datas and getting the result as specified. Okay, so then what is mean by operands then? The data on which the operation is being carried out are called as operands. Okay, so I have already said you what are the datas. So here we are having A and B as the datas. So this data is performed the operation. So that's why it is called as operands. So here the datas are considered as an operands. So read the definition carefully. Don't mix up with operators and operands. So it's very easy topic. So we have 3 examples for addition, multiplication and exponentiation. Hope you understand this topic, and let us move on to the next part of the video. So we are going to read the first part of the operators called Python arithmetic operators. Okay, so you have already studied in mathematics many types of arithmetic operators you have studied, likewise addition, subtraction, multiplication, division, etc. So as like same in the mathematics, we are having some arithmetic operators in Python, but there are some differences, small differences. So first one is your addition operation. The first operator is addition, so it is giving you the result of A plus B. Okay, the next one is your subtraction. It will be giving you the subtracted result of A minus B. And multiplication, it is multiplying the two datas and giving the result as received. And division, so under the division part we are having 2 parts in Python. So one is your division and another one is your float division. So compare these two and study. Okay, so whenever we are dividing any two values by using this division symbol, so the result will be in the decimal value or a floating value in Python. Okay, but on the other side, this float division will be returning the result in the integer number or a whole number. So let me take one example. If A is equal to 4 and B is equal to 2. So if I'm dividing 4 by 2, so it gives the result as 2.0. But in mathematics, if we are dividing 4 by 2, then it will be 2 only. The result is 2. But in Python, it gives you in the decimal value. That means 2.0. So on the other side, in the floor division, if we are dividing 4 floor division 2, then it gives you the result as 2. So that means it is giving the result in the integer value. Understand? So the next one is your modulus operator. So this modulus operator will be giving you the remainder. Okay, so it returns the result as remainder of the particular division. So suppose if you are having 4 modulo division 2, so the result is 0. Yes or no? As because the modulo operator will be giving the result as remainder. Okay. If we are having 5 modulus 12, so what is your result? So you should compare the first value with the second value. If the first value is lesser than the second value, then the result is your first value. Understand? The next one is your exponentiation operator. So it is nothing but specified as double star. That means a star star b. So it is nothing but a to the power of b. Okay, a to the power of b. Suppose if you are having 2 star star 2, that means you should multiply this 2 times 2 to the power of 2, which is 4. Okay, so we are having the precedence of exponentiation operator as right to left. So all the other operators except the exponentiation operators will be working from left to right. Okay, so see the addition will be working from left to right precedence. Subtraction is same, left to right precedence, and multiplication is also left to right precedence. So make a note of all the precedences, and modular division and division is working on left to right precedences. So it is also modular division is also working from left to right, and floor division is also working from left to right. But the exponentiation operator will be working from right to left precedence. Okay, let me give another example. If we are multiplying 2 star star 3 and star star 2, so it will be taking the result from working from the right hand side. So it takes first 3 to the power of 2. So 3 to the power of 2 is 9, and which gets multiplied with the previous number. Now it will multiply 2 to the power of 9. Okay, which gives you the result as 512. So you should know the differences and the precedence on each and every operators and how it is working, so that you can able to answer all the 1 mark questions, 2 mark questions, and while you're doing the output programs, you can able to easily identify those. Okay. So let us move on to the next slide, which is your Python comparison operators, and it is coming under the relational operators. So the comparison is nothing but we are comparing with the 2 values. Okay, just we are giving two values and we are comparing that. So the comparison operators will give you the answers either in true or false. So it gives the result in either true or false. So just the first one is equals to, just it checks for A double equals to B. Okay, it checks for A is double equals to B or not. For example, if I am giving A is equal to 10, B is equal to 12 and C is equal to 10. So now we can compare with this. A double equals to B. So A is 10 but B is 12. So it is not equals to. So here the answer is false here. So the next one is not equals to. So the symbol for not equal to is you can able to put this exclamatory mark with equals to. So now we are going to execute this A not equals to B. That means 10 which is not equal to 12. Is it true? Yeah, it is true. A is not equals to B. So it is true. It is not equal, right? So that means 10 is not equals to 12. So it is true. The next one is greater than symbol, A greater than B. That means 10 which is greater than 12. So your answer is false here. Likewise, less than symbol, A is less than B, which is true. And A is greater than or equal to B. It is false again. And A is less than or equal to B. Okay, A less than or equal to B. Yeah, it is true. So hope you all understand the Python comparison operators. The next one is your Python logical operators. In mathematics, you have studied logical gates, AND gate, OR gate, NOT gate. So likewise, we are having it in Python also. So the first one is your AND, OR, NOT. So these all the operators will be returning the result either in true or false, like the comparison operators. These two will be returning the result in either true or false. Okay, so let us see the AND table now. So what the AND table will be doing? AND table 1 1 1 0 0 1 0 0. So the AND table, if both the things are true, if both the values are true, then the value is true. If both the values, if either one of the thing is 0 now, not true means the whole thing is false. So likewise 0 1 is 0, 0 0 it is 0. And what about OR table? So many of the students are having the confusions in this calculations for calculating AND table and OR table. Okay, so likewise 1 1 1 0 0 1 0 0. So if both the things are true now, then it is true. That is 1, right? That is 1 1 1 1. If any of the value is true, then the whole value is true. So that means the value is 1 here. So 1 0 1 0 1 1 0 0 0. Okay, this is your OR table. So the non-zero values are considered as true here. Okay, so the non-zero values are considered as true. 1 is also considered as true and 0 is considered as false. Okay, so this is the explanation for AND table, OR table. So see the description for AND. It returns true if both the statements are true. Okay, likewise for OR table, it returns true if one of the statements are true. And NOT table, so it will be reversing the result. Okay, so NOT table is nothing but it is reversing the result. So if we are having not true, then the result is false here. So it is an inverse result that will reverse the result. If it is not false, means the answer is true. Okay, so let us move on to the next slide. Hope you all understand this logical operators part. So the next type of operators we are going to study is Python identity operators. So the Python identity operators are basically used to compare to two memory locations. Okay, so comparing the memory location of any two objects, so you can write a notes for that. So it is used to compare memory locations of two objects. Okay, here we are having two types of ID operators, that is and is not. So both will be returning either in true or false. Understand? So see the description here. It returns true if both the variables are of same object, and is not, it returns true if both the variables are not the same object. So for example, I am creating A with 100, see the right hand side, and B with 200 and C with 100 again. Okay, now I am checking that A is C. So what is the answer now? So A is C. The answer is true, as because A and C are having the same values. So if we are storing the same values, so though all the values will be stored in some same memory locations. Okay, so now I'm comparing with A is B. So automatically the answer is false here, as because A is 100 and B is 200, both are the different numbers. So the different numbers are stored in the different memory locations. Okay, for example, now A is 100 now, then it is stored in the form of 100 like this. A as 100. Now I am giving B as 200. So this B is going to store in separate memory location. This is B. Now again I am giving C is equal to 100. So it checks for the same type of value where it is getting stored. So this 100 already is present in A. So again it is storing that 100 in the same memory location, that is C. If I give different any other numbers, D is equal to 500, then it stores that in the next memory location, which is your different memory location. So if the same objects are shared for particular variables, then it returns true. If it is not shared the same object now, then automatically it is returning the false. Okay, so there are few cases where the Python will create two different objects that both stores the same value. Okay, so we are having some few cases where the Python is creating the two different objects. So the first case is that input of the string from the console. So the user input. So it is according to our user input how we are giving the input in the console. Okay, so the way it displays the memory location and it is getting stored in the memory location, and for very big integers. For example, if I am giving 1, 2, 3, 4, 5, 9, 0, 1, 2, likewise, and B is equal to the same number 1, 2, 3, 4, 5, 9, 0, 1, 2 now, then both are the same numbers only, but as this is a very big integers, all the things will be stored in separate memory locations. Okay, so writing the next case is that writing the floating point and complex numbers. So you all know floating point and the complex numbers. If I am writing A is equal to, so let us write A is equal to 5.6, A is equal to 5.6 and B as 5.6. So both the things will be stored in the different memory location. This 5.6 will be stored in the different memory location as because it is the floating point numbers. Even though it is same, it shares the different memory locations. And for the complex numbers also same thing only. Okay, the complex part of the numbers also is the same thing. 2 plus 3j. So again I am going to store with the same value in B, 2 plus 3j. So these will be sharing the different memory locations. So A will be stored in something and B will be stored in some other memory location. So if it is a small number, then it shares the same memory location. If it is a big number now, it will share the different memory location. And if it is a floating point, means it does not share the same memory. And if it is a complex numbers also, it does not share the same memory locations. Okay, so likewise how the input which is we are given by the user, according to that it will be acting up. Okay, so hope you understand this Python identity operators. Let us move on to the next type of operators called membership operators in Python. So this membership operators in Python is also returning the result either in true or false. So this is nothing but in and not in. We are having two membership operators, which one is in and not in. Example. So let us teach one example for this membership operators very easily. Let us take a variable called string, which is equal to Python. Okay. So let us check h in string. So the h is a small letter word which is present in the string or not. We are checking by using this in operator. So under the string variable, we are having Python. So in this Python, we are having the value, that means the character as h here. So that means it returns the result as true. So let us check for capital H in string. So check for capital H is there in the string variable. So we are not having the capital H. So it returns false. Understand? If you are writing capital Y, not in Python, not in string. Capital Y which is not in string. So it returns true as because it is saying the true thing. So this capital Y is not in the variable string here. So now we'll read the description. It returns true if the sequence with a specified value is present in the object. So this is called as a sequence. The string is nothing but the sequence. So it is working only for the sequences. So for string, list, tuples, so etc. this Python membership operator will work upon. Okay. So this not in operator returns true if the sequence with a specified value is not present in the specified object. So example A in B, A not in B. Okay. So hope you understand this membership operators thoroughly. Let us move on to the next type of operators called augmented assignment operators. So this is nothing but plus equals to, which can be written as A plus is equal to B. So I have said you this as shorthand assignment operators. Shorthand assignment operators. So we can say it as like this. Okay. So this might be asked in the 2 marks or objectives. So this plus equal to can be written here with the data as A plus equal to B. So what is the exact meaning of this? That means A is equal to A plus B. So likewise for plus equal to, minus equal to, star equal to, division, floor division, okay, modular division, exponentiation is equal to, and equal to, or not, greater than or equal. Okay. So we can have all those operators by using this shorthand assignment operators. Okay, we have used left shift and right shift operators also. So let us study the next topic under this bitwise operators. So we are having the operators like AND, OR, XOR, NOT, zero fill left shift and zero right shift. Okay, so this bitwise operators are doing what? It works on bits. Okay, so you know what are the bits? So bits are nothing but zeros and ones. Yes or no? So it works on bits, that is binary values 0s and 1, and it is used to perform the bitwise calculations on integers. Okay, so first of all it will convert this integers to binary, and then the operations are performed on each bit, okay, or corresponding pair of bits. So that's why it is called as bitwise operators. Okay, so finally this result will be written in the decimal format. For example, bitwise AND. So sets each bit to 1 if both bits are 1. Okay, example, if you are writing suppose if we are writing bitwise AND operator, so we are using the symbol AND for this. So it returns 1 if both the bits are 1. It returns 1 if both the bits are 1. Okay, suppose if we are having A is equal to 4 and B is equal to 5. So what is the binary value for 4? Okay, ASCII value for 4, that is 0, 1, 0, 0, and for 5 we are having 0, 1 and 0, 1. So we are having bitwise A and B. Now we are performing A and B. That means if it returns 1 if both the bits are 1. So otherwise it returns 0. So 0, 1 0, 0, 0, 0, 1, 1, 1 and 0, 0, 0. So now we are having 0, 1, 0, 0. So which is equals to 4 decimal. Okay, next one is bitwise OR. What is bitwise OR? So it can be written as, this is the symbol for bitwise OR, and it returns 1 if either of the bits are 1. If either of the bit is 1. The same example, A is equal to 4 and B is equal to 5. So let us write 0, 1, 0, 0, 0, 1, 0, 1. So it returns 1 if either of the bits is 1. Any of the bits is 1 now, it will be returning you as 1. 0, 1, 1, 0, 1, 1, 1 and 0, 0, 0. So 0, 1, 0, 1, it is the decimal format for number for 5. Hope you all understand. So next one is bitwise XOR operators. So let us see bitwise XOR. So the third type is bitwise XOR. So it is denoted as this symbol. It returns 1 if only one of the two bits is 1. Okay, it returns 1 if only one of the two bits is 1. Okay, so example, A is equal to 4 and B is equal to 5. I am having the same example for all the things. 0, 1, 0, 0, 0, 1, 0, 1. So it returns 1 if only one of the two bits is 1. Okay, that means one of the two bits is 1. So 0, 1, 1. Either one value has to be 1. Then only it can be written as 1. Oh my god, sorry. So it returns 1 if only one of the two bits is 1. If both the bits are 1 now, so it is returning you 0 only. Sorry for this. So it is returning you 0 only. So 0, 0, 0, 1, which is the equivalent to 1 decimal.